In this video, we're going to be looking at finding the nth term of linear sequences. Now, a linear sequence is a sequence that goes up by the same amount each time. Let's take a basic example. Let's say 3, 5, 7, 9, 11, and so on. This term is going up by 2 each time, so it's related to the 2 times tables. The rule is that we add 2. Now, because we are adding 2 each time, I know it's related to the 2 times tables, which means that it is a 2n sequence. If you compare it to the 2 times tables, 2, 4, 6, 8, 10, and so on, you can see these 2 sequences are really related. To get from the 2 times tables to this sequence, we just add 1. So it is 2n plus 1. That is the nth term. The nth term is a way of finding any number in my sequence. Let's say I wanted to find the 100th term. Well, to find the 100th term, you let n equal 100 and put it in here. So we do 2 times 100 plus 1 is 201. Now, comparing to the times tables is fine, but there is a much quicker and easier way of doing it. Let's take another example. Let's say we're going 5, 8, 11, 14, and so on. We are in the 3 times tables because we're going up by 3 each time. The rule is add 3. That means that it is 3n because we are jumping by 3s each time. Now, I can compare to the 3 times tables, but the quickest way to do it is just to go back 1 term. If I go back 1 term, I minus 3 off, I get 2. This is the number at the end, the plus 2. That is the nth term of my sequence. Let's say I wanted to know the 50th term. Well, what I would do is I'd let n equal 50. So I'd do 3 times 50, and then I would add 2. So 3 times 50 is 150, plus 2 is 152. That's the 50th term in the sequence. Let's say I wanted to know, is 24 in the sequence? Now, obviously, what you could do is you could just count up by 3s each time. But if that number 24 is a bit larger, it might be harder to do. What I'm going to do is I'm going to say that 3n plus 2 equals 24. This is saying that my nth term equals the number that I want. If I get a whole number, then it is in the sequence. If I don't get a whole number when I solve the equation, then it's not in the sequence. So if I subtract 2, I get 3n equals 22. And then I'm going to divide by 3, so n equals 22 divided by 3, or 7 1/3. Because n isn't a whole number, that means that 24 is not in the sequence. You can do that for any number, asking whether it's in the sequence or not. It doesn't matter. But what's key is that if n were, say, 20, that would mean that 24, whatever number you're looking for, is the 20th term in the sequence. If you don't get a value, then it's not in the sequence. Let's do a slightly different example. Let's say we've got 100, 80, 60, 40, and so on. Well, this time, I'm going down by 20 each time. That means that we're looking at minus 20n. Now, you could do the minus 20 times tables if you wanted to and compare them, but the easier way, as I said before, is just to go back 1 term. If you go back 1 term, we're going 40, 60, 80, 100. The next term would be 120. So it is plus 120. This works if you're dealing with decimals as well. Let's say we had 10, 8.5, 7, 5.5, and so on. Well, I'm going down by 1.5. I'm subtracting 1.5 each time. That means I'm looking at the minus 1.5n times tables. And if I go back 1 term in the sequence, so 5.5, 7, 8.5, 10, the next term is 11.5. And that is my nth term of this sequence. The last one I'm going to show you is to do with fractions. Now, let's say I've got 3 over 10. 5 over 9, 7 over 8, 9 over 7, and so on. Now, what a lot of people try and do is they try and convert it to decimals, and they try and work out a pattern from that. Much easier way. Let's just look solely at the numerators to start with. 3, 5, 7, 9. You can see that I'm going up by 2s, and that means that it is a 2n pattern. If I go back 1, I get +1. That is the nth term for the numerator. Easy. Now if we do the same, but this time we look at the denominators, 10, 9, 8, 7. I'm going down by 1, so I minus 1n, or just minus n. I go back 1 term, I get +11. And that is how you would do the nth term for fractions as well. Just consider the nth term of the numerator, then the nth term of the denominator.